In this video, I'm going to show you JSquelch, a Squelch application I wrote. It listens to audio input, and if it detects voice or other non-continuous audio signals, it will turn on an LED and record the audio to disk. It will also pass through that audio to the sound card so you can listen to it live. It's non-responsive to any color of noise or any arbitrary noise distribution, as well as continuous tones. So if you have an interference, which is a sine wave, it won't respond to that. Or if you turn the volume up, it makes no difference to it. The reason for making this application was I wanted some more experience with AI and was hoping I could use some sort of neural network. However, it turned out I didn't actually need any of that AI stuff, and it's a lot of moving windows, various moving stats, moving minimums, moving maximums, moving means, moving variance, that kind of stuff. It uses a Fourier transform to divide all the frequencies up, so that's how it can ignore single frequencies of interference. So let's check it out on voice. We will change the input to microphone, which is me, and now it's listening to what I have to say. So if I speak, the LED comes on and it realizes someone's speaking. When I stop speaking, there'll be a delay caused by the JSquelch delay of about a second, and then it'll turn off. And while I'm speaking, the audio of what I say will be recorded to this location. And it is this file that is being recorded. So when I stop the application, I'll be able to open with, and now it's listening to what I have to say. There's a slight delay, you might even be able to hear that on the, to turn this down, otherwise it will cause feedback. So if I speak, the LED comes on and it realizes someone's speaking. When I stop speaking, there'll be a delay caused by the JSquelch delay of about a second, and then it'll turn off. And while I'm speaking, the audio of what I say will be recorded to this location. And it is this file that is being recorded. So when I stop the application, the purpose of this application was to record voice contacts between planes and the tower, so that the contacts could be written to disk without having a whole lot of blank periods of time where no one was speaking, because most of the time those HF frequencies, no one talks on them. You get a quick burst of 30 seconds where a plane is contacting a tower, and then you have a few minutes where, or a few hours, I don't know because I haven't really looked into them a great deal, where no one is talking. So the idea here is it records just the voice contacts and ditches everything else. So let's give it a go. To test my application for the purpose that I wanted it to be used for, I went to WebSDR and used a receiver in Washington DC, tuned into one of the frequencies that are used for HF communication by airplanes. I then recorded some audio using this record audio function. I then imported that audio into Audacity and then started my application. All of this is noise except for around 30 seconds around the 3-minute mark where a plane contacted the tower. I'm going to play this recording into JSquelch, which will identify what parts contain the voice and will record them to this location here. So the audio from Audacity is going through one of the virtual sound cards, and that's going into JSquelch. This here is its estimate of the signal to noise ratio of the one I described in my write-up. You can see it's not affected much at all by these little blips of noise that you hear. There was a slight increase just at that point, but it's still well below the SNR threshold of 9 decibels. I've also got some hysteresis, so it actually has to get to 11 decibels before that green light turns on. And you'll also notice there's a slight delay between when the audio is played and when that shoots up a bit. but without these little glitches here, it's around 3.5 decibels. Slight increase up to about 4 decibels after that point. And there's almost no variation in SNR going through this glitch. So these little parts that go down and up have more effect than these peaky things. I think this is probably some AGC thing that the SDR receiver has. So JSquelch probably works better without anything with an AGC, would be my guess. Now we'll be getting to the voice around here, so this should shoot up.
New York, United 1173 position. United 1173, good. United 1173, position 2G 2045, flight level 340, Aponu 2101, Gale, next, kill 14.3. Copy at 2G 2045 at 340, Kano 2101, Yale, next 14.3, 40 south at Kano, call New York 133.5. 33.540 south of Makoto, United 1173, good day. You as well, take care.
And there it goes, there's contact. So now it's played that audio file. If we go into here, we can see it's recorded an audio file. I'll stop that. Now if we play this,
New York, United 1173 position. United 1173, good. United 1173, position 2G 2045, flight level 340, Aponu 2101, Gale, next, kill 14.3. Copy at 2G 2045 at 340, Kano 2101, Yale, next 14.3, 40 south at Kano, call New York 133.5. 33.540 south of Makoto, United 1173, good day. You as well, take care.
so you can see it got rid of all the noise, and it only recorded the part where the voice was. So that's my idea of this application, what it would be used for. Yeah, but it'll be out for others to actually try it out, because I'll probably never use it.
Copy at 2G 2045 at 340, Kano 2101, Yale, next 14.3, 40 south at Kano, call New York 133.5.
They might as well be speaking gibberish.